Okay, so here we have parent functions, and then we have resultant graphs that can just be a different version of that graph. So if I look at this graph here, this is my parent function. It's the most basic. It goes through the origin, and it's just y equals x. Over here, I have y equals x, but written a different way. And because it's written a different way, it's considered this is considered its parent because it's the main version of that graph. When you have a parabola, same thing here, and this is what a version of that graph could look like. Here, the parent function of the square root, and here's a different version of that graph. With these, when I have 1 over x, okay, you'll notice, of course, that x can't equal 0, and that I can also write it like this, because when we have a negative exponent, we just divide by it. All right. Also, here I have numbers raised to x. Okay, depends on if the number is big or small, what's going to happen. And then here I have a log. Okay, and these again are just different versions. This would be a different version of this parent function, and this would be your basic absolute value. And of course, here's a different version of an absolute value. Also, when you are doing inverse graphs, all you do is you take your x and your y and you switch them. Okay, so wherever my y was, we'll have an x, and wherever my x was, we'll have a y. Okay, and when I do that, I'm just solving for y, so I get a new equation. So here I subtracted 3, then I divided by 2, and then I had y squared left over. So when I take the square root of that, it gives me y is equal to, and then the square root of everything else. Another question that has come up is, what if I have something like log base 2 of x? Okay. Well, if you have something like this, all you do is in the calculator is you put the log of x all over the log of 2, and that will get you the same thing. And I think that's everything.